Good day, viewers out there. This is your favorite channel, The Tutor Home. We are back again to introduce this wonderful topic, and we'll be considering this particular question in regard to velocity time graph. We want to explain a particular question. I love this question so much because this question involves reality. It involves what we do every day. Now, if we pick these questions, you discover that we have a car start from rest and accelerated with a velocity of 20 meters per second for 5 seconds. It maintained the speed for another 5 seconds until a brake was applied and brought to rest for another 5 seconds. Calculate the total distance covered by the car. This is a very wonderful question and questions that often come out in exam like WAEC, NECO, and JAM. So please follow me as I introduce you to the step we take. Now, before you can be able to solve questions like this, you must have the velocity time graph. You must sketch out the graph that undergoes the journey. So now let's start by, we have the normal illustration of a graph. But because we are considering velocity time graph, so we have the V, which is the meter per seconds here. We have the V with the meter per seconds. Then we have the T, which is in seconds. That is the velocity time graph. Now, this is our origin. We are being told that the car starts from rest. That means the car initially started from rest. So the car moved to a certain point and amounted to what? 20 meters per second. So this is our point of velocity. We'll have our 20 mark there. Now, at that point in make 20 velocity, we're told that it was at the time 5 seconds. Now, we're told again that the car maintained that speed for another 5 seconds. That means it didn't go up and it was just moving forward for another 5 seconds. And we have another 5 seconds there. Please, you don't put 5 here. We can't put 5 here because you put 5 here, it means that the distance that it was actually moved is no longer 5. So you make this 10, so that if you minus 10 from 5, this particular distance between here to this can actually be 5. Then we're told again that brake was applied and it came down to rest for another 5 seconds. So when brake is applied to a car, what happened? The acceleration dropped. So it came down to rest from that 5 seconds. And again, don't forget, if you put 5 here, you are simply saying that the distance here is not up to 5 and the question will be wrong. So you add the new time to the previous time, which becomes what? 15, which therefore means 15 minus 10 here becomes what? 5, according to the question we're given. So this is a sketch about the total journey that the car made. Now we are asked to calculate for the total distance cover. Now, if you consider this factor, this diagram, you discover that this is a diagram of what? A trapezium. This is a diagram of a trapezium, and a trapezium, the area of a trapezium is simply is simply 1/2 bracket a plus b times height. 1/2 bracket a plus b times height. We can either use the area of a trapezium to solve for the total distance traveled, or we can either solve for individually. Look at it. This is a triangle. And this is a rectangle, and this is another triangle. So we can either use area of a triangle plus area of a rectangle plus area of a triangle. So these are the two ways we can solve questions that involves total distance travel. But I'll be using this particular formula to solve this question because it's shorter and it's brief. Now, we are applying the area of a trapezium, which therefore means that is the total distance traveled in the journey is simply 1 over 2 bracket A plus B bracket H. Please mind you that the distance between here to this point is H. So this is our H. The distance between this point to this point is our B. It's our B. The distance between here to here is our A. I'll go over it again. The distance between this point to this point is our B. 0 to 15 is our B. Then 5 to 10 is our A. Then 0 to 20 is our H. So if you understand that, we have 1 over 2 bracket. What is A? A is the distance between here to this point, which is what? Simply what? 5. That's 10 minus 5 plus the distance between this point to this point, that is what? 15. Then times the distance between here to this, that is what? 20. And we'll do that, we're going to have x is equals to this plus this, that's give you times what? 20 times 20. And if we do that, we're going to have x is equals to 1 over 2 times 20 times 20, we have 400. Okay, so x is equals to 2 going to 400, we have 200. So s equals to 200 meter. So this is the total distance traveled by the car from the sketch diagram that we have. This has come to the end of this edition. Please don't forget, subscribe to this channel for notification when we drop new video regarding subject like this. Thank you.